Okay. Good evening. This is Group 24, and this is our final year project presentation called EduReach, which is a gamified mobile application for enhancing basic education in resource-constrained environments. Moving on to the introduction. So I'm going to give you a brief background that pioneered this project. First of all, we identified that there are many children in these resource-constrained environments that lack access to digital learning tools. We also identified that internet connectivity as well as electricity and device limitations are found in these resource-constrained environments, which we can practically see. There are not very many areas that are constrained, that have proper internet connectivity or even a stable electricity supply. And some areas do not even have access to these devices. For those that do, they have the low-end devices. Then we've seen that we saw that gamified learning has shown positive impacts when it is implemented in education, since it improves engagement of the students as well as retention of what they learn. Excuse me. So our problem statement involves the existing educational gaps often require internet access, which is true. Most of the applications available these days, be it for learning or for leisure, require someone to have a stable internet access to be able to fully exploit the application resources. We see that most are resource intensive and unsuitable for the low-end devices, which we already said is what is present in these resource constrained environments. Then few of them combine literacy, numeracy, pronunciation, and activity recognition in one offline platform. So, what were our research objectives for this project? One, which is our main objective, was that we wanted to design, first of all, to implement, and then to evaluate a lightweight, fully offline gamified mobile application specifically for children aged 4 to 8 years, which is a stage where people get the foundational skills of communication. Then our specific objectives we saw was to identify these key foundational learning skills, which we mentioned before, where we had pronunciation, literacy, and activity recognition as well. Then to also develop a lightweight offline application. And our third specific objective being to evaluate the usability and educational value that this application would bring. So the scope of our study, as I mentioned earlier, our main target group was children in between ages of 4 to 8, which is where most children get the basic foundational skills. So our platform was targeting Android devices, mainly the low-end Android devices, which is what I already explained is found in these resource-constrained environments and a fully offline application. So the main learning modules within this application include the activity recognition, where these learners get to identify activities, everyday activities such as sweeping, reading, then object recognition, where the learners are required to identify simple objects around them, things like balls and pencils. Then word pronunciation, where the children's vocabulary is improved. They're taught how to pronounce these different words. And then math and counting. So moving on to the literature review. So the literature review basically highlights the other applications that exist in the educational scope or that facilitate learning for the different age brackets. So one is Colibri, we have Kwamsha, Ubongo Kids, Eneza Education, and AfriLearn. So out of all these applications, the main findings that we got is that they don't have really a good offline support for the learners. Two, they have limited pronunciation support. Most of them are tailored towards the storytelling side, which doesn't really enable the learners to gain hands-on experience in learning pronunciation of simple objects. Then we also saw that they have limited activity recognition. So most of them are simply storytelling applications and whatnot. Then the resource demands remain very high. Most of these applications are very resource intensive. They have high storage capacities, require a lot of internet, which is not accessible by people in the resource constrained environments. Then the research gap. So from our literature review, here are some of the gaps that we identified. So out of all those different applications that exist, there's no integrated solution that combines activity recognition, pronunciation, numeracy, and we also saw that there is limited optimization for the low-end devices, Android devices in particular. Then also there's insufficient support for the resource-constrained environments. These applications are not really tailored to fit the resource-constrained environments that well. So we gave a proposed solution, which is our application, EduReach. So I'll now hand over to my next colleague to take you through our methodology. Thank you.
Yes, good evening, everyone. This is Rosemary, and I'm going to be taking you through some parts of our project. First, I'll begin with the methodology. So in our methodology, we combine the user-centered design and the agile methodology. So the project was executed using 5 main phases, and that is the requirement analysis, where we did the research on what is lacking, what we need to develop, like what were the research gaps. Then coming to the system design, basically we came up with the prototypes on how the app was supposed to be looking. Then on the next stage, we came up with a working application. Our fourth stage involved testing the app to really see that is it satisfying the needs we identified in the requirement analysis. Then finally, we refined it and made a report for that. Then moving to the next step, we have our system architecture. And here we use the model, the view, the control architecture, and mainly why we chose this is because this separation gave us a clean code for easier maintenance, better testability, and also like the smooth state management. Like it also helped us to efficiently implement like the offline functionality and the resource saving feature, as you're going to see as we explain. So this is it. So we had the view controller, that is mainly the one that handles the event where the kids interact. Then when we come to the controller, it has the game loop manager, we have the audio input engine, then also our echo mode that minimizes battery uses. Then finally on the model layer, we have the storage where it tracks the progress of the child using our application. So moving on to our development tools. So we developed this application using Flutter and Dart, but then other tools we included was VS Code as the editing IDE. Then also we used the Android Studio for profiling because it's like the most common low-end device. Then also we had to use JSON and SQLite, that is for storage and the recording, the audio play packages, and also for pronunciation. So basically, when we talk of its UI, like we use the UI, we use the Figma, Canva to ensure like it's simple and attractive for the young children. You know, for them, they are always so active and engaging with things that are attractive. So here, I'm basically going to take you through what our core application includes. The first one is we have the activity recognition. And here, when the child logs into the app and chooses the activity recognition menu, it displays an activity, then plus the options, like the several options where a child is to select from, like I have here, when I open an application and go to activity recognition, it displays like an example. This is a person reading a book. So here it displays with answer options. So the child has to choose one. When it is correct, it prompts you to go to the next question. But when it's not correct, it asks the child to try it again. So the next one is we have object recognition. So here, same thing, same like activity recognition. Okay, for activity, it's based on what people are doing at that particular time. But then when it comes to the object, it displays several objects, and that is, okay, when it displays the object, a child has to choose the right option. If it is right, prompts to the next question. If it is wrong, asks you to try again. Meanwhile, it also records your session log, like your performance, and rewards you with coins. The next one is we have a word pronunciation. So for the word pronunciation, when you click on that specific menu, we have the audio embedded in there. So that audio pronounces for you, like the way you're supposed to pronounce the word. An example here we have read. So when you click on the audio, it reads out for you the word aloud. Same thing like this one, it tracks progress and rewards the coin based on your performance. Then last on that, we have math and counting. Here, child learns to count, and also it has some parts whereby you do some simple calculations with answer options. Then moving to the eco mode, this resource reduces, like, I can say the eco mode mainly reduces like the battery uses and the resource consumption. That is basically what it does. Then, yeah, I think that is it for that part. Let me invite my next colleague to summarize.
Hello, everyone. Good evening. I'm Namkwaya Irene, and I'll be taking you through the following part. What I'm going to take us through is the data storage design, where we have the offline persistence, and it involves the JSON serialization and the SQLite database. So this one helps us to store our data from the app, and it records the progress tracking, the rewarding of coins, and session logs. And here is our diagram from loading in the user progress, like till when, like in case, like you just follow the diagram, just for the sake of our time. It is just showing us how our application flows when the user starts inputting the data from logging in up to when the data is saved. Then we also have testing and evaluation of our application. And here we use 5 evaluation methods, where we started with the unit testing, and we first tested each small part of our EduReach application. From unit testing, we moved on to integration testing, whereby we combined all the small parts of the of the application that we had worked on. So we combine them all together and then test to see if the flow is a smooth one without any disturbances. Then we moved on to functional testing. And here we see if what we actually implemented is what the app does. From there, we did the hardware profiling, where we check if our hardware can work properly. For example, the phone following the size. And also we had our heuristic usability review. And here we based on if experts, like when experts check, like what are the results shown. So we also had the key results, and here from our functional testing, the results are as shown below. We have offline mode success, which is successful. Then we also had progress saving, and it is also successful. We had the echo mode, which is operating, and also the pronunciation, which is working, plus this stable navigation across all the modules in the application. Our achievements and contributions, we have a fully offline and educational platform which supports foundational learning, including progress tracking, and also the echo mode for battery efficiency. And our contribution is it promotes equitable access to digital education. So we have also our limitations and future works, where we had like no field testing with the children, and also had to test on limited device models. And the future works are here, like we need to conduct real-world deployments, add more learning modules, support local languages, and expand caregiver analytics. For the conclusion, we had a successful EduReach application, which shows that it is a lightweight and fully offline gamified learning application. So on our conclusion and recommendations, we see that EduReach successfully shows that a lightweight, fully offline gamified learning application can support foundational education in these resource-constrained environments. And we recommend that it is deployed in rural schools, also conducting large-scale user studies, and also extend the curriculum coverage. So our references, we had a few of our references from the report, and some are here. And that was all from Group 24. Thank you for listening.